Hello. Thank you everyone very much for joining. I am Hemin, and I will talk about a library that I am currently working on. It's called Decrel. So before I start, let me talk about myself a little bit. So I am uh, I am Hemin. I I have this GitHub handle called yoohaemin. And I'm a backend engineer in SmartPay in a company called SmartPay. SmartPay is in Tokyo. We are doing what do you call it? Buy now, pay later, atobarai service in Japan. Our office is near Shimbashi. And personally, I love Scala. As Scala was the first, maybe not exactly the first, but I only do Scala since like 6 years ago, which was not too far away from my first Hello World. And right, so about my library, I started working on this library since about a year ago. And it's basically pretty simple. It allows you to declare relations between domain entities, and then you can use those relations to build efficient queries to fetch data from databases, or you can compose generators in your tests. So I actually did a talk about the motivation of Decrel, about the design and like what and some other aspects of the library in functional Scala at December. I think the YouTube video was out a few months ago. About, I think, around January. If you are interested in the motivation, then I suggest you check out that talk. It's called Declarative Data Access with Composable Relations. However, today I want to talk about some realistic example. So I didn't know if I yesterday. It's very minimum. It's very so. I have this example project called the shopping cart example. So maybe I will jump here. There's so this is the card for this book. This excellent book called Pure Programming Scala. By Gabriel Volpe. And it's also an excellent example application for actually making some modifications. So my plan for today is to add Decrel to a real code base, which is this application, and then we'll see how it goes. All right. So say you're managing this application. And then you need to, let me actually show you the code. Let's see. Right. So if you go, oh no. Yeah, by the way, all the code is just available in GitHub. So you can just actually, yeah, you can just see like what is going on here on your own as well. So this is an HTTP4S application, and here is a route. So what it does, if you look at, it's an auth route, so it only doesn't reach this route. And then you see, oh, it's a get endpoint, it's a order ID and user value ID and then order ID. So task again to modify the existing get orders ID endpoint and add an optional parameter expanded. When expanded is true, I should return the item details of the order. So actually, let's take a look at what this actually is. If you go to orders.get, yeah, if you look at order, so if you look at the items field, is map of item ID and quantity. So it doesn't actually give you back the item details, but it's only the item ID and how many of that items exist. So maybe the front end wants a new page and information, and they want to give back everything about the item. So I think this is pretty realistic example of like what you would work on day to day. And all right, so let's look at the naive implementation on how you will solve this. So this is like actually my shot at doing that. I'll just show you the diff. So this is the order routes. It had the order repository already. Now it also needs to depend on the item repository because we also need the item details. So I extract the expanded query parameter, and if it's false, then we just do this. But if it's true, so if we actually want to expand, then first we get the orders, and then what you do is so this returns an option. So I want to do a .toList, and then for each now for the order I have the item. So I have a set of items that is in the map, and then for each item I do a find by ID, and then like somehow return everything here from the for comprehension. So this actually works, but the problem is it is a little inefficient. So it calls database so many times. And then it's also a little hard to extend. Like if we also want to have an endpoint that actually returns one more thing, then we have to have another if branch with like another information, or if that is too much, then if that is too much if and else branches, then we might just modify the existing routes as well. So if we want a different pattern, then we would add another if case, like somewhere here, and we would have more duplicated code. And then there's also the thing that if you have this long code inside the routes, there's something I don't really like given the routes has this much logic. I think it belongs somewhere else. So this is the naive approach. There is a problem that I don't really like. So I'm going to show you the declarative approach using my library, which allows you to define relations and then using the relations to actually go back to my different branch that I prepared earlier. So, okay, maybe this is a little too much. The first thing you need to do is obviously go to build.sbt and you add these two dependencies. Actually, only this one. The next one is for later. So Decrel.fetch is a cast-effect integration using the fetch library that allows you to actually access data from the database. And the next thing you do is actually very simple. You go to and this one line. So this actually is an arrow from an order to item. So this is conceptually, if you have an order, you must have a list of items because because that is just how it is. An order is tied to many items. So if you have an order, you must have multiple items. So you only add this line. And then you need to provide so this looks actually pretty complicated, but let me explain from top to bottom. So this is just a module of the application, like any other modules in your application. It requires some repositories, and then it has to extend this fetch. So fetch is something that's provided by the Decrel library. And then inside it, you can define proofs for your relations that you wrote already. So this thing, order that items you just saw, case object items extend relation.many. You call implement many data source, and then you put in this order that items, and then you implement this function. So what this function is this thing called batch execute. So given a list of orders in this case, you have to give back a list of an f of list of the order and a collection of outputs, because we told them, oh, there's a from order to item, there must be many items for one order. So you have to provide a tuple of per one order. You have to return the collection of the item. So you just implement this as you would implement any other data access code. And then, like, if you implement it, then it's now your relation is actually usable in code. So what you can see here is in the order routes, I need to now depend on it. So this order route requires proofs as well. And then I do an import proofs. And then so I have ordered the items that I just wrote here. Like this is case object that I wrote. Then it gives me an f of item, f of actually list of items. So you can actually see here is the items is option of list of items. The option is from this traverse. So this thing, if you look at this thing, then just a list of items. And this order and the items. So this is a different approach using Decrel. So it's actually I don't think anyone add this new library Oh, okay. Thank you. Thank you very much. Okay, so let me actually have bring another to was returned from the routes. So say let's actually look at the item. Item actually has brand ID and category ID. This I modified a little bit from the original project, and then the same way I can define brand and category relations. So okay, so this one a relation to a single item to brand, and another one is from item to category. Means if you have an item, you must have brand. If you have an item, you must have. If you go back to the routes, say if I also want the brand details and the category details.
Please share screen.
Okay. I'm very sorry. I'm very sorry for this. So here, where was I? Yeah, so I add brand or category details to the response of that endpoint. Then what can I do? So that is like exactly like this. You can add different relations from going from item. So from item, I've defined these two already. So brands and category. So brand, this relation basically means if you have an item, you must have a single brand. This one means if you have an item, you must have a single category. So same way, you can provide the proofs. It's a little messy, maybe I can make it more. So this one from item, so this one is for the brand. So if I have a list of item, I have to return a list of tuple of item and brand. So it's defined actually here. So here, if with a list of item, I have to return a tuple of list of item and the brand. So you would just implement it in the same way, and then yeah, right. You would implement it the same way as any other code, and then you can just compose them in a different way. So you would have items dot brand and items dot category. The category. If you do that, the types change. Yeah, and it becomes a list. Before it was a list of items. Now it's like list of item, brand, and category. And then like what you return also changes list of item, brand, and category. So it's actually really simple to do this. If you only want the brand, then you do this. If you only want the category, you do this. Yeah, so I've also prepared another slide another slide demonstrating the how to compose your generators. Apparently I don't have any time left, so let me just. Yeah. Yeah. So this is how you would use it in the tests as well. So it's a bit abrupt, but I just wanted to show people how you would compose the generators as well. You would have these composed relations. So you already have it. You provide a generator here, and then you call expand, and then from that I call order.self. So this first one is still the order is from the order.self. It just passed through the generated order from here, and then I generate some items, and from the item I generate the category and the brand. So if you look at items, there's a list of item and the category and the brand. If I only want the category for the test, then you just change this. And if you look at here, this items is needed item and category. If you don't want the category as well, then you only have order.items, which gives list of items. So this is a pretty convenient way, I think, to build complex generators for your tests. So that's it for my talk. To sum up, you identify your relations in your domain. You write it down using the one-liner way I showed you. Improve your relations by providing an implementation, either database access or generators, and then you can compose them. And it will run efficiently because they're all optimized, they're parallelized or batched. And yeah, you can also incrementally adopt, only adding the bits that you need. And yeah, that's it. This is very experimental. Still, I've been working on it for a year, but still a lot of things to do. And if you're interested in contributing, I can help out with all the weird implicit stuff that actually works behind the scenes to wire all the proofs for your composed relations. So if you're interested in learning this bit, please let me know. I will help you. So thank you very much. I'm sorry it's over time.